Good. We'll start in a few minutes here. Just give me about 5 minutes to let all the peoples come in, and then we'll go ahead and proceed. Okay, hello everyone. I think we've waited long enough. We're going to go ahead and proceed. I know it's Friday and everyone wants to go home and have fun and be with their family. And so without further ado, let me introduce everyone's an artist and engineer and an engineer 2014-2015 the C-STEM VEX Robotics Teacher Training. Welcome. I'm your moderator and host, Felipe Resendes. The training today is going to consist of a brief instructor introduction. We're going to go through the training. I apologize. I forgot one more click here. Let me just proceed here, but just welcome again. I forgot to hit record, and I apologize. Welcome to the again, everyone's an artist and engineer 2014-15 VEX Robotics Teacher Training. We're happy you're here today. Again, going back to it, instructor introduction, training breakdown today, instructor polling. I'm going to ask a few questions from everyone, and I would like your sincere cooperation in this and response. We're going to briefly talk about workforce applications of robotics. We're going to go through the kit of parts in detail, and hopefully I can give you the best explanation of every part that's out there and what it's used for. We're going to go through the programming process. We're not going to learn all about programming today. That's going to be later for the C-STEM break if you have any questions. I am going to give you, though, very good helpful links where you guys can go and actually gather more information and even have your middle school or high school students actually do some research and do independent study and learn as you go along. We're going to talk about the engineering process, what it is and how you can apply it to the VEX training and the C-STEM challenge, and which is a very good thing to do. We're going to talk about strategies. What's the best strategy for you? We're going to talk about real quick. We're going to define gear ratios, torque, speed, and payload. And we're going to go through some of the helpful links that I've added to this real quick and give you some tips and hints and the future training deadlines that are coming up. At this point, are there any questions before I proceed? I want to go ahead and welcome everyone that is still coming in. So welcome. So there are no questions. Everything. If you have a question, please use the little hand on the right top hand side to raise your hand, and I'll try my best to answer as we go along and read your question, and then post an answer so everyone can see. A little bit about myself. I'm your instructor, Felipe Resendes. I'm currently an employee. I apologize. My current employer is Samsung Tech when I work for a division of Samsung. I'm pretty sure everybody knows that name. I work with the engineering and sales teams to manufacture centrifugal machinery, or what we call turbo compressors. These are large air compressors for big manufacturing plants or different processing of gas and energy in the energy industry or in the oil and gas. I'm basically kind of like a liaison between the two and trying to spec out for different customers information and making sure they get the right equipment that they need. Brief history about myself: I was born in Monterrey, Mexico, but I grew up in South Texas all my life. Was the first in my family to graduate from high school and actually attend college. And I obtained my degree from the University of Houston, where I reside currently, and also attended Texas A&M University, the College of Engineering. My robotics experience basically was introduced to robotics a few years ago. I've always had a passion for technology, math, and science. I became an educator and lead teacher for our engineering academy that I and a couple of teachers helped start the academy there at our school. Became a Project Lead the Way certified teacher in digital electronics and also engineering design. And became the robotics sponsor. A couple of other areas of expertise are networking, computer maintenance, and also computers security. I was introduced to robotics in 2007, and from there on I was hooked. I was a student for the first year. I'll be honest with you, I learned more from the students than they taught me. I participated, then I helped the students in many different competitions, first robotics competition, best TSA VEX, just to name a few, and a few Lego competitions. We've used platforms like the National Instruments Compact Rio, the VEX EDR, which we're using today, the Lego Mindstorm with programming languages like LabVIEW, RobotC, and ECC, just to kind of give you a little summary of what my experience with robotics. Our training for today, middle school and high school, from 5 to 5:45. I'm gonna try to, make that time. And I apologize, we started a little bit late here at the elementary level with little glitches here going on, but it was nothing on our end. 5:45 to 6. Hopefully, have questions and answers, and I'll try to get to you guys out of here as soon as possible. Like I said, I know it's Friday and everybody wants to go home. So please, if you have any questions, try to type them on the little text chat, and I will try to answer as I go along. But if you have a detailed question that you want to ask me, let's try to leave it for the last 10 minutes so we can proceed with this training, and I'll try to do my best to answer it there. If not, I will try to post it on the System Break website, and hopefully you guys can, once you log in, we'll be able to read the responses or get helpful links. Real quick question for everyone so I can get a better understanding that's here with me today. How many teachers have participated in a robotics competition in any aspect as a teacher, mentor, parent? If you have, please state yes, no, new to System, new to robotics. Just go ahead and brief description, what competition or what event you guys did, and what role did you play? And have you ever used a different platform other than VEX? No, new. Okay, we have a one yes. Vanya. Okay, System and VEX Coach. Excellent, excellent. So um, we got first time. Okay. I think Ms. Norwood, you were there earlier. Well, no problem. The training is very similar. We're just going to go through a little bit more depth on the kit of parts and other stuff as well. Robotics club years ago as a student teaching. Okay, excellent. Lego for summer school. Okay, so you guys understand a little bit more about robots than my previous class, and you play with robots as well. Okay, and Mary, thank you. Chemistry teacher, this is the first time. No problem, no problem. We're gonna try to help you as well. So okay, thank you. Um, Again, guys, for those of you that are new, be patient, be open, and best advice that I can give you is be a student and become the teachers along the way. It is something that if you like math, science, I mean, this is excellent to see the kids react when they do something and all of a sudden it's working and it's moving and it's doing what they're supposed to. I mean, and they get so excited they get hooked. I mean, I've had seniors that during my engineering classes they were like, I wish I was involved in robotics my freshman year, or I wish I saw you guys out here. I'm I regret not actually not regret. I'm sorry. I regret not joining you guys earlier, but it's a very exciting and very rewarding. Real quick, like I mentioned in our previous competition, you do make a difference, believe it or not. I have a lot of former students attending schools all over the country: Texas A&M University, University of Texas, University of Houston, Colorado School of Mines, MIT, etc., that have gone through the robotics experience, and now they are actually working with Fortune 500 companies. Students with patents and awarded contracts that are helping the medical field. I mean, that was a very big surprise a couple of years ago when a student came by and said, "Mr. Resendes, everything you taught me about the engineering process, everything you taught me about, we learned in robotics and in digital electronics, I was able to apply all this information, and we were able to submit a prototype and we won the contract, and now we're all like, it's very rewarding. Like I said, it's, stuff like this really makes it time. So hats off for you guys being here today, and I'm gonna definitely encourage you guys to continue, so give you the best training possible. All right. What's the first thing that comes to robotics? I guess when you think robotics, some of you already have experienced robotics. So for those of you that have not been in robotics before and this is your first time, what do you think? What is the first thing that comes to mind when I say robot? Can I please get a quick response? Transformers. Okay. Any of your new teachers that engineering? Okay. Excellent. Transformers engineering. All of that is correct. I mean, they go hand in hand. Interactive. Okay. Excellent. 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 So um, those are all right. Programming. Thank you, Vanya. Thank you. Thank you. Again, for many people, it's a machine that imitates a human, like the androids in Star Wars, Terminator, Star Trek, The Next Generation, etc. However, much of these robots capture imagination. Such robots still only exhibit in science fiction, although that is basically changing. People still haven't been able to give a robot enough common sense to reliably interact with a dynamic world. However, Rodney Brooks and his team at MIT Artificial Intelligence Lab are working on creating such humanoid robots. This type of intelligence known artificial intelligence. So AI is the basically a robot that's able to do tasks without being told anything, and be able to modify against the parameters and the conditions of the world, and do as the objectives appear, and think like a human being. So that's basically what artificial intelligence and what's the next step on the robots. For most of us, unfortunately, this is what we know robots for. Um, we have different applications in the medical field. We have a surgeon here basically doing some type of medical procedure that if he would have probably been able to do it with his own hands, he might not be able to actually get it done. On the bottom left, we have an ROV, or remote operated vehicle. These little machines are used widely in the oil and gas industry. Which are allowing them to go into further depths and help produce energy, extract oil from the bottom of the ocean. And these machines are helping with manning the operations of the blowout preventers, the Christmas trees that need to close and open, and redirect the flow, et cetera, and connecting all the units there at the bottom. So these are remote operated vehicles. And then we have land operated vehicles, which are, our military is pretty much used to, and allows them to go through, take video, or be part of the landmine detection system, which allows them to explode landmines before our troops walk through the actual fields and stuff. So we have manufacturing. This is what we have and we're used to doing. Our manufacturing facility in Korea uses a lot of robots to manufacture some of the parts I was telling you about. They use robots here. We have an automotive plant doing the assembly and most of the work that humans used to do on a routine basis. And of course, there with sensors and different motors, they're able to create movements like humans do. And we have our little buddy here on the right hand side that for education, this has been kind of the latest craze here with this little guy as well, and allows it to walk and program, etc. And I apologize, I completely forgot the name of him, and if anyone knows, please share it with us. I've seen him a couple of years ago at a teacher training, and it was an awesome little guy there, walking, moving, talking, reacting, etc. So, any questions so far from anyone? Are we okay so far? Okay, yes, okay. Thank you. Now, thank you very much. There's the name of the little guy. Yes, thank you, Vanya. It's an awesome little humanoid-looking robot that it's very popular too. Well, moving right along, the kit of parts. We're going to cover the middle school kit of parts. So if you're a high school, this also pertains to you. The only difference is middle school teachers, when it comes to the high school kit of parts, I'm going to ask you guys to, I'm going to ask some of you guys to actually just take a quick break, etc., because this will not pertain to you when we're dealing with competition. So just to kind of give you an idea, let me grab a quick link to this kit here, middle school, and I'm going to go ahead and go through the kit of parts. Okay, see. All right. Classroom and competition programming kit. This is basically for middle school and also applies to everyone in the high school level. I'm going to just go through it. When you go to this link, and I posted all these links online, you'll see them on my presentation, and you guys can go to C-STEM break tomorrow, and they'll be able to pull the presentation. This is just kind of like an overview. You'll be able to basically have an idea of what it is. For those teachers that are new, pay attention. For those of you that are veterans, I apologize. This is basically just a kind of like a once over, so please bear with me. Maybe there's something you might not know. I might be able to kind of get a good idea. Okay, Vanya, I know you're probably the expert here as well. So the link will take you to the VEX robotics kit of parts, and basically just to kind of give you an idea, for those of you that don't know, you'll have an ability to go in there and take a closer look and click on the icon, and unfortunately I'm going to switch over to the PowerPoint here in just a little bit, and we'll be able to see it closely and go through the whole process, and I'll try to explain as much as possible what all the items are. And again, it comes with a robot kit, the VetNext bundle system, additional two 393 motors. These are your large motors. It comes with a robot battery, joystick, and chargers. And we're going to go through it in programming add-on kit, 2 motors and 7 sensors included, and also free design software from Autodesk. So take advantage of this, the Autodesk designing software. It's an awesome little tool to have kids do your initial prototypes or sketching the ideas, the different ideas that they might have using the Autodesk software. Very good software. We use it almost at a daily basis here on my job at Samsung TechWin. It's very good for kids to learn this now, so when they get to high school or college, they have a good foundation using Autodesk. And if you can get a free license and do it in there, please try to have them design their ideas using Autodesk. It might be a little bit of a learning curve, but I'm pretty sure they're able to figure out, because instead of playing video games at home, they could be doing this, and trust me, it will pay off in the quick future. Just to kind of give you an idea, at the bottom, aside from the bundles that we're talking about, every part is listed. The kit of contents, the manual, the claw, etc. Just to kind of give you a little hint, if you ever say, for example, you want to know how, the motors, you click on one of the parts. A lot of these parts are going to have, are going to open up to another window. You have different parts and what everything, the shaft coupler looks like, what it means, how it comes in the box when you get your kit. Okay, and also the main thing, the name of the motor, okay, what ports you connect them to. For example, the motor connects directly to 2 wire motor ports, port 1 and 10. So you have to connect those motors on those ports on the Cortex microcontroller, which is the little box. Okay. For a 3-wire motor ports 2 to 9 on the Cortex. So it tells you if it has 2 wires to connect it to, you connect them on 1 and 10. If it's got 3 wires, you connect it between 2 and 9. A motor controller 29 must be used between the motor controller and the motor. So this little motor is going to be connected to a motor controller, which I'll show you here in just a little bit. If I go back, let me see the motor controller. Motor controller. Let's see. Might be it. I don't. Yes. Oh no, this is not it. I apologize. The encoder pack. This is for rotation and other things here. Where are you? Oh, motor controller. Apologize. You have 5 motor controllers in this kit for the middle school. So this is your motor controller. You plug in your motor here at this end, and then you plug in the other end to the actual Cortex, or the little box between those numbers that they were mentioned. Going back to the motor real quick. Going back to the motor. To kind of give you an idea, and I'm only using this as an example. You can go through it on your own and have kids go through it and research if they want to know more about the parts. But a lot of these parts have a CAD file that you can actually look at it in a different spec. But the most important that I like about these is that you have a download and document section, and there's an instruction sheet. When you click on the instruction sheet, you are able to actually get a breakdown of the motor, a little bit more description of the motor and what it does. Builds a rotational mechanism using the motor, drive bases, rotational joints, conveyor belts, or anything that spins that can be built using a 2-wire 393. Okay? It tells you where to connect again. It tells you high-speed options. It gives you the option of actually, if you want to go faster, you can increase the speed up to 140%. Want to go faster than the standard motor, but still have the same output torque as a standard motor? No problem. The 2-wire 393 can be configured into a high-speed or turbo version. Simply follow the gear change procedure, step-by-step instructions to increase the output speed by 140%. So as you go along, it tells you that it can go from 100 RPMs to 160 RPMs using the same motor. And then you have to actually go in there and do some modifications. Okay, so you can go in there and change the actual gear ratios, and it tells you how to change the little gears and what motor couplers and stuff you might be using as well. But you need to open the motor, step 2, take the shafts out, take the gears off, install a new middle high-speed gears, and just reverse the process and seal the motor again. Like I said, every part has something of that nature. Some of these might even have a video that you can look at and actually tells you a little tip on how to set it up, or how does it look like once it's assembled. So please keep this in mind when you're out there working. It's a very good way for you guys to actually be in there and actually see how it might look like if it's not built. See this one, for example, all the dimensions and how it gets assembled, the assembly process, if it ever gets disassembled. So a lot of these have a lot of, like I said, a lot of different documentation that's very, very helpful. I learned a lot about them because when I first started, I was clueless about VEX. I had just been in FRC for years and BEST, and then we had to actually use all the different hardware that came with VEX. BEST is just the same microcontroller and the Cortex, but it's a different. You use wood, etc., that comes in with a kit. Just to kind of give you an idea. For high school, I'm going to switch over for high school at the moment, and then I'm going to come back. Or actually, I apologize. Let me go back to the next screen here. Here it is for middle school kit of parts. Hope everybody can see it as best as possible. I try to enlarge it and put it on the presentation. You're going to get the bundle, the startup bundle that you get, and here you're going to include the wheels. You are going to include the motors. These are the motors, and it's a little hard to see, so bear with me. These here are your Allen wrenches. These are allowed, so you can tighten using some of the bolts. These little black ones, you use the Allen wrenches here, the little keys that you can use to tighten up motors. You can attach motors to the frame, etc. You can do different things. You have your gears. These are your actual different gears that you can use. Your keys to allow to tighten up the nuts and bolts here. These are the nuts and bolts. These are some zip ties. Allows you to secure, for example, a battery. You can zip tie the battery and then make sure it's secure, create a little cradle around it. More zip ties for little things, maybe these little zip ties that go around electrical wirings. use electrical wiring so you can guide as you build, and the wire doesn't get in the way and gets chopped off. So definitely use zip ties, very important. These are supports, so you can add different motors and little add little spacers in between. Again, these are your nuts and bolts. You get a pre-built claw with this package right here. So this claw, I'm almost positive it comes in pre-built. If not, follow the instructions like I showed you earlier. It tells you how to build the claw, and it's really awesome. So go in there. All the framework is all the silver I-beams and H-beams that you have here in different types of sheets of this metal. Allows you to create the bases and everything you're going to be creating with the actual VEXnet, all the different connectors and shafts. These little shafts here is very important. These shafts typically help you create the extensions for the motor, so you can add sprockets. There's ways of doing it here. There's some more here. These are extensions they use for you can cut them and do like motor shafts as well, so they can wheels. You can make them for wheels, so the motor and then the wheel gets attached to this part, and then you can use one of the little one of these little couplers to keep the wheel in place. Rotating here, we have a couple of sensors. These little red ones are all sensors. Anything you see red is sensors with VEX. You have a stop sensor. When it pushes the sensor, it sends out a signal and it stops whatever it's doing here. There's little buttons here. You have a limit switch. Say you have an arm and it's moving and it hits the little switch, it should send out a signal and stop the rotation of that particular arm. You have potentiometers that actually measure the radial distance as it turns. It tells you how many rotations the motor has done over here. You have a light ultrasound sensor. This is basically sound. If I can't remember the exact dimensions, but they are listed on the VEX. They are listed on the VEX distance. As soon as it starts reading that distance, you can make it stop or change rotation or do it as a feedback. It allows you to incorporate feedback of motion. So if you're about to run into a wall in autonomous mode, it can sense it and maybe you can program it so it turns the other direction. These little things here are just LED markings. Sometimes you might need a signal. They light up. They're little LEDs. You can put them on one of the little ports here that it tells you they're specific ports and lights up in case you need a type of feedback and sensor. Your battery pack, this little blue one here, anything blue is battery, electronics. Green typically is gears and wheels. VEX, these are your AA batteries. It's always good to have extra batteries on hand and always having them charged. I always have a system set up during competition where as soon as he comes back, plug him back in there and charge him. Good, very good tip. This is your 7.2 volt direct current battery. This is your charger. You plug it in and you charge the battery. When it turns green, the battery is fully charged right here, and it goes plugged in on this opposite end, and this goes into your here, and then you use this wire here and plug it into your wall, to your AC, alternating current. These look like small motors. It's kind of hard, and I apologize. I'm going to have to look at the list, just to make sure that these are the they look like the 293 motors, those smaller motors for VEX. Now we're coming with the VEXnet microcontroller, and then you have your controller and your VEXnet. Basically the brains. This is where the brains. This is your computer, basically. This little devices here that you see are USB transmitters and receivers. They send information out and they receive information. So one goes underneath the controller right here, and then the other one goes in this little slot on top. As you pair them, basically, I know we're going to be talking about pairing here in just a little bit, but once you pair them, you should be able to communicate back and forth. All these are for rotation and spinning. I apologize, I forgot the name of them. I'll come back to you guys in a little bit. This little looks like a 9-volt little case. That's what it is. This is actually a battery backup. When this battery runs out during competition, because your kids forgot to maybe recharge it between competitions, this little battery, you pop in a 9-volt battery, goes onto the microcontroller. It still receives signals. It doesn't allow the controller to burn, and whatever is running, it should allow you to continue running some of the motors, etc. If you still have a charge on your controller. So very important as a backup. It's a backup battery resources. Everything else, you have a couple of chains here on top. These are little chains, so you guys can create some chain mechanisms, gears. You can pull levers. These these little, I can't even, they're like little gears but made of rubber. We've used them in the past to maybe use some type of sweeping motion or some type of motor so they can sweep and pick up stuff. Very important for them to use for that particular purpose. So don't lose these. These are very, very awesome to use. And your wheels, your 4-inch wheels, your standard wheels. This is the middle school. And you also get 2 omnidirectional wheels. So basically these move forward and side to side. Very cool wheels to use if you have access to these. So these are the omnidirectional wheels. Any questions at the moment about the kit of parts? So like I said, everything's going to be listed. Everything's going to be listed on the kit of parts right here. When you go back to the VEX, website, and it will tell you what everything is, from a washer to a nut to a screw. Everything you have is going to be basically the C channels. There we go, bars. What everything is, you'll be able to see a picture. And if you don't know, this is your first time, take the time to go through the kit of parts. Have kits, if you have to, maybe make a printout, a little, and as you learn and go through the whole kit of parts as well. For high school. So middle school, I want you guys to take a quick break and just kind of hang out for a brief second. Well, we go through the kit of parts for high school. This is basically everything the VEX have to offer. You guys are getting. You're getting the middle school competition kit, the starter kit, and then some. This is basically the kit and caboodle here of what we're getting. Basically, we got your wheels, your 4-inch wheels. Again, everything that I talked about here earlier, so I'm just going to differentiate a couple of things that I saw different. You get some brackets and braces that you don't normally get. You get these little, I forgot the name of these, but they allow you to do torque and able to make slides with a motor and a gear. You can slide them up and make them come up kind of like on a lift, like basically a lift on a side, or you can move horizontal or vertical movement. You can do these. You're able to extend, make extenders. You also get tank drives. You can actually make a tank drive. Instead of wheels, you can make tanks now. You can set up your motors and you can set up some of the wheels here like they are here to create tank drive mechanisms. So you gain a lot of the stuff to create a tank drive, and also more of the grappling, pushing in, kind of like a vacuum. The rollers that are spinning to vacuum in or push information in. Again, you get the VEX's controller. You get more connection, more wires. I see some. It says lost audio. Can you guys hear me? Can you guys hear me? Okay. I hear lost audio. So, okay. Give me some thumbs up or little smiley faces if we're still good. Thank you, Mary. Thank you, Modesto. Okay, we're good. I guess it must have been on your end, Vanya. I don't know if I got full bars here. Can you hear me? Okay. Vanya, you might have to log in and log back out. Can you log off and in? Give me 1 second, guys. Okay, going back, you still have the push sensors, the limit switches. Again, you have some motors, more framework. I mean, you guys get it all, guys. You guys get a lot of frame. You guys can really create and get creative with building, maybe not just one, but possibly even 2 robots. I mean, if this is the case, you might have one as a backup, and in case something happens to the other one, you get a lot more hardware, as you can see. But again, the VEX and controller, railings, now you can create lifts that can go up and stick out and bring stuff up. I mean, you get almost everything they're getting, and then some, a couple more things. Like I said, you get some sprockets and gears here at the bottom that were not available. You can create, and you get more chain right over here, so you can extend this and maybe make, do some type of motion with these gears.
You also get a heavy-duty set of gears. Now, these gears tend to break off when you put a lot of force and pressure to them.
But these gears that you see up here, these are your heavy-duty VEX. They're reinforced with metal. Most of the time, they have these little metal parts that they go in here.
So when you throw in the shafts, they are reinforced. So these are very hard to break, and the teeth are very hard.
They're about 2 times as wide as your normal sprockets are.
These are very good if you're doing some application where you need a constant lifting or turning or
some type of torque, high torque areas. These are your sprockets you're gonna be working with. You get some hinges, rubber bands to store energy. Maybe
you don't have enough force because the motor's too weak. Well, now you have rubber bands. You can maybe allow them to, pick that arm up or something that you might
be able to do, or use some type of store energy with rubber bands as well. So it's for you guys to get creative with all this. Any questions so far? I mean, it's just a matter of you guys going through them and figuring things out. Like I said, more framework. I mean, you guys get everything, and then some. So you get some of the high-end accessories for VEX. So this is a very cool kit here. Are we good? Okay, I'm going to move on right along. Again, the parts. So go back to my link, go through it. Ms. Norwood, we're good?
Okay. Are we okay? Okay, yes.
Our programming instructions included. We have a question. I think that's our next topic here, programming here. Let me
clarify that. Very good question, Forbes.
Pairing. There is a basic set when you pair the controller to the Cortex that's automatically put on the controller. This little box, the VEX
Cortex that's already pre-installed to everyone.
So when you actually pair this controller, you can actually plug into port 1 and 10 and everything else, and there's a very basic forward, back, left, right programming built in. Now, if you want to build an arm and you want to use another trigger finger or use some of those little triggers to activate something in your robot,
well, then definitely, yes, you're going to have to program it and have your students learn a little bit about programming. The program that we're going to
be using for C-STEM this year is called Robot C. And Dr. Flowers
and the staffs here at C-STEM is going to be able to, they're going to be passing out the information
on how to access and get yourself a license for this software. I'm also including some links where you guys can go and learn a little bit more
about Robot C. I will try to do the next system break trainings,
micro trainings to maybe give you guys some examples.
If you guys can post on the system break forum, if you need some help, maybe give you guys some ideas on coding.
It's something that you can definitely assign some of your students that want to learn coding to kind of take it on their own and learn as you go. I will give you kind of general overview because it's very difficult to teach programming in the amount of time that we have here. Basically, it's going to be a very difficult task to do, but if I can give you at least direction and extra materials, you should be able to figure out how to get this done. Does that answer your question, Ms. Forbes? Code Academy, okay. Thank you. All right, again, pairing is basically making, like we do now, our headphones to our cars. Pairing is the communication, wireless communication between the controller that sends the signals when you push the buttons or the sticks and sends information to the
actual Cortex. Every Cortex has inputs here, where if you have
a motion sensor, you have to put it on a specific port. A motor, like we said earlier, 1 and 10. If you have between 2 and 9, if it's a 2 to 9 pin, and then you have a lot of different ports. So the instruction will tell you the ports, and also I've included on my on the actual presentation.
It should have the quick start guide on how to use the Cortex and how to pair. This will be a basic, very first step
you guys need to do when you open your equipment, and you want to make sure that you're communicating with the
actual Cortex. Maybe hook up a motor in the battery, and once it's paired, you'll be
able to push the throttle button, and it's going to move and spin in one way and then the other. That's
basically the first thing that you guys want to do. Make sure that the Cortex and the controller excuse me, are communicating with each other.
From there on, just a matter of uploading new programming if you guys want to do, and coming up with the solution that you guys are going to implement and how you're going to get it done. And again, you can use this microcontroller, plug in the USB, and you can actually plug it in underneath as well, the USB, and you can actually run it without having to have the wireless keys if you want to have it tethered, which is mean hooked to the microcontroller Cortex box. You can actually run it that way as well. Any questions about pairing? Are we okay?
I'm going to move on along. You have a question, please name it. Again,
Programming your robot, we're going to be using Robot C. Robot C is a C-based programming language used in
education, robotics, and competitions. Using Robot C, you'll be able to instruct your robot to carry out tasks autonomously as well as respond
to the inputs of the controller. So as your students grab the robot and you press a button and you want it to trigger something or make it something move or make a motor, move a gear, you'll be able to program it that way using Robot C. And again, there I have some links that you can go to Robot C as well and be able to help you with programming your robot and installing the software and the basic steps of actually setting up your computer,
your folders, etc., where everything's going to be saved and how to run it. It gives you some examples as well. So you're not alone. There's a lot of information. Just a matter of I guess if you want to take it upon yourself and learning, definitely you can do that, but there will be plenty of online resources. There are many engineering processes that exist.
We will follow the VEX 11 step, and again, this is on the VEX curriculum, and I've made a link to it down here at the bottom if you're going to follow it. If you guys, this is when I was in the engineering academy, we had something called engineering design and development, their senior course, and basically we followed this 11 steps the whole year, where students had to actually come up with an idea, prove it, and basically generate ideas, research it that nobody else has actually done it, and go through the whole process of developing a prototype and presenting at the end of the year. And this was our senior thesis, and we followed a very similar 11-step process. So it's very good to have this implemented on your C-STEM. If you have time, go ahead and implement something similar, where step one will be, hey, let's define the problem, guys. What is the objective of the field? What are we supposed to do? How are we going to score points? How are we going to have that technical advantage? What can we do? Everybody's got the same level playing field because the kit parts are the same. It's all about how are you going to be able to strategize with your students on how to be successful and how are you going to get more points and lead this competition. And then you can go on to explore, do a little bit of research and background if you need to develop some programming or if you're developing some type of gear ratios and stuff, etc. like that. It's something you guys can definitely start exploring and doing it with your students. Determine the solution once you sketch. Here's where the engineering notebook comes in place. We're going to talk about here in a little bit. It allows you to document as you go along. Hey, this is defining the problem. Write down what the problem is. Write down what the background research we need to do. Write down what some solutions. Let's everybody brainstorm. And there's no wrong brainstorming idea. Write them all down. They'll come back and say, remember I had that idea earlier in the year and you knocked it down and you made fun of me. Now we're going back to it, and that's our best idea. So write them down, have an open mind, brainstorm with your team. It really helps to get these ideas down on paper. Generate concept solutions, start narrowing it down. Once you narrow it down and say this is the solution we're going to follow, let's prototype. Okay, this is what we're going to do. We're going to do a 2-arm lift to get this done, or we're going to do 3 claws and be grabbing 3 balls at a time, or I don't know the objective of the game yet. So once you do, you'll be able to basically come up with a prototype and start building. At the prototype state, we actually have kids working on the VEX, putting it together, doing the hardware, doing the drivetrain, which are the wheels and the columns, and then you have people working on Ivania, we will post the link to the chat. They will be posted online as well. They're being recorded, so this will actually go on the C-STEM break as well. Ms. Forbes, you can't hear me? Let me see. Give me 1 second, guys. Okay, I'm adjusting my mic to its highest potential. Can you guys still not hear me? I mean, I have full data up here, so okay. Thank you, Vanya. Again, okay. Again, refine, choose a final concept, go with one, refine an idea, especially you high school, you have so many parts that you might be able to do two teams and say, hey, we're going to build two robots, and whichever works best,
we're going to go with that robot, and then maybe build another robot similar to it to have it as a backup. That's kind of an idea for you guys out there.
keep that in mind. Always have a spare robot. It really helps because something can burn out between matches, and then you'll have something ready to go
without having to actually go out there and trying to work through the last minute.
Okay, and finally, present. I'm pretty sure System's got a way to present and feedback. Maybe have your teams present their solution in front of peers. It really helps. Maybe some other teachers and see which one's better. Or at this time, maybe present it at the System competition if there's an object
a presentation as well, and then implement your solution and test it out.
See which one works best, and if not, come back and do it again. You know what? We've tested it out. We found that we have a problem that we have to address, and let's rework it into the equation. Let's prototype. Let's get some ideas and come back again. Okay. That's definitely the engineering process we'd like everybody to follow. And I'm going to move on because we're almost 6 o'clock. Here's an example of the engineering notebook. Guys, have kids just a regular notebook. We used to use the college engineering notebook, which is a square inch, allows us to draft the different angles. This is a very good example of what we used to do. Okay, we're going to do a catapult, or we're going to do a gear. This is some very good examples. You can see, take pictures for maybe future use. This is how we're going to do the gears. This is how we did. This is how we add them to the robot. Problems we did this day, this meeting. What we're going to be doing is sketch them out, have kids sketch out a prototype. Everybody has to turn one in, that kind of stuff, so they're getting involved and get ownership of the idea, and you'll get a very awesome team if everybody gets ownership and gets involved, and everybody's ideas count. Very good thing to do. All right. One of the strategies that we're going to be definitely talking about today is gear ratio, torque, speed, and payload. I'm going to just brief to it due to the lack of time, and I apologize I spent too much time going through the kit of parts, but I feel like this really helps people kind of describe what everything does. Gear ratios, they depending on the gears you set, you can make things go faster or slower, or have different torque ratios, so a motor be able to pick up an arm, etc. Speed, how fast you're going to be able to, the object is going to be able to move, and also remember that the more you carry, the slower probably you're going to be able to travel. So their speed and payload are inversely related to each other. So keep that in mind when you are actually discussing with your students, and go through this a little bit more. But just to kind of give you an idea for those that are new, we have an example. We have the 100 revolutions per minute, which is how fast a motor spin that you get out of the box. And if you put a gear of a 1-to-1 ratio, exactly the same size, it's going to spin at 100 revolutions per minute. But if you change the gear ratio now, say for example your motor is here and your wheel is here, you're going to be running probably at half the speed as fast as the other individual that might run a wheel here. Still going at 100 RPMs, or vice versa. You put your motor here and then your wheel here, you're going to be going faster than the guy doing the 100 RPM. So by manipulating gears, you can actually manipulate speeds on these, either on the motors and even on the wheels when you set up your wheels. And again, real quick, motor and speed and motor torque, they're really related. So the low load, you're going to go much faster, versus high load, you're going to go a lot. So it's motor speed versus motor torque, and it's just RPMs versus Newton meters. So the equation between the two, speed versus load torque. Something you guys can talk about with your students if you're going to be with an issue with speed. Like I said, it just depends. Connecting the dot. Science designs robots that cures diseases at a cellular level. If you want to use it as a science experiment, what are they doing? What are some of the nanotechnologies that are being used at the moment to cure blood diseases or certain diseases inside the body? What are we doing? Technology. And an example would be enhances the automotive industry to create driverless cars. We're getting to an era where cars are becoming more and more enhanced and automated. There's even a couple of years ago when we worked with National Instruments, the C-RIOs were given to us because there was a demand on the FRC that they wanted people to build autonomous cars. And there was a big challenge out there. I think the winning university would get $5 million, and there was cars out there that this university's built that they were actually traveling across the U.S. unmanned, and they were able to cross from cities to deserts without anyone basically at the wheel. So, engineering, design robots to explore where humans cannot. Some examples can be deep water drilling.
the Mars rover and nanorobots. The little picture here is the actual Mars rover prototype that won a couple of years ago. They rolled out there at the one of the competitions, and I happened to be sitting right next to a table, and here comes this this thing sideways that uses crab wheels, and they rotate 360 degrees, and it moves in every direction. So they were planning on sending this to actual Mars in the near future. This is kind of like their pod for them to actually travel in, to be the vehicle for them if the astronauts. So that was a very cool thing to see. It was just a one-time deal showing that particular event. Mathematics, why do we need mathematics? For some of you guys that are math teachers, we need programmers to code the AI for these robots. So it's all related, connecting the dots with robotics and science and technology and teaching. So hopefully you guys can do the same thing. Try to do the connect the dots with your students. Some helpful links. Now this will be on the C-STEM break tomorrow. Like I said, the education website, Carnegie Mellon University, has a lot of stuff on robots. VEX curriculum is very good. Gives you a lot of ideas on how to get stuff done and started and concepts if you're not familiar with them. robotc.net, and I think someone contributed earlier. I just saw someone contribute. Let's see. Someone said something about training earlier and mentioned a website academy, Code Academy. So there's a couple of things out there definitely that you guys can share, and that's what I want you guys to do. And for fun links, if students are interested and want to know more about BotMag and then Servo Magazine, there are actually ways to keep your kids interested as you go along. From now on, the training is communication and sharing is going to happen. All training info will be shared on C-STEM break. Saturday workshops will take place on C-STEM break. 90% of the teacher communications from now on to teachers and students will take place using the C-STEM break. So try to log in and log in and get this happening. So there's a log on screen as well for new accounts as well on the C-STEM break website. On C-STEM break, teachers and students are encouraged to, number one, blog. Share resources like we just resource here on Code Academy. Definitely any pictures, guys. This is what we're doing. This is what we're doing. Check us out. Put some videos out there. Helps, encourages people to go. You know what? We're behind. We're going to do something similar. The people start getting ideas. Everybody starts sharing. The juices get going, and everybody starts getting really competitive. So engaging, collaborate with other teams across the competition areas in grade levels. Chat live with trainers. If you need help, we're going to be doing those training sessions. Clarify send clarification questions to us. We'll try to answer them as soon as we can. And students should compete for the top ambassador award, and teacher should compete for the STEM Teacher of the Year award, which is presented at the competition. So keep that in mind. So all the communication is going to be done through C-STEM break. Here is a please don't mind the 2015. There was a quick error there. Thank you. That should be 2014. October 1st, introduction. That's going to be the C-STEM challenge tomorrow at 10 o'clock Central Standard Time. So please, it's not 2015. This is kind of like the setup. The next times we're going to meet: November 15th, December 6th, January 10th, February 7th, March 7th, and April 4th. Please put them on your calendars. I'm gonna vary the training that it says here a little bit to give you guys more of the programming. If you need help, try to help you guys with some code. Maybe you guys can pair. If you have any issues with the robot, some questions. If you have maybe some ideas, try to guide you the best way I can. So you guys can be successful on competition. So I'll definitely do those 15-minute trainings and then posting and try to answer questions as best as I can and post on the C-STEM break. So keep that in mind. These are the deadlines or the dates. I'm sorry. A couple of hints. Remember to use the engineering process if you can. It helps in student learning. It helps them come back and say, you know what, I had this idea yesterday. Here it is. Okay, let's develop on it. Okay, so it really helps using. I'm an advocate of it because I've seen it work. And I used to teach a whole year class, and kids can always come back and go, you know what, I have this idea, and it's here. Now I can implement it because I don't have to rethink about it or et cetera. I have all my data here. You can change the gear ratios on all motors. Remember that. And also, the 2015 C-STEM Challenge is related to energy infrastructure. So keep that in mind. Try facilitating dialogue with your students that allows them to develop a winning strategy for their team. Don't forget to constantly point the engineering process along the way. Have fun as you learn and teach your students.
And last but not least, here's your last website. The next step, to complete your training, please join the 2015 TTI group on CSTEM to answer the discussion questions. We're posting some discussion questions in the VEX Robotics discussion thread, so please go out there and answer those questions with and try to have your students definitely participate and get feedback from them. I came up with some questions. Hopefully they're worth your time, and they're going to be very good discussion points at this point. How is robotics help with these questions? You'll be provided a certificate of acknowledgement for your completion of 2-hour training. Remember to plan your CSTEM challenge kickoff activities on your campus. The challenges will be unveiled tomorrow at 10 a.m. Central Time. So remember, plan something fun and exciting to kick things off with your students. And after kickoff, I will see you again on Saturday workshop, November 15th, system. And like I said, contact me, send me a link. And I applaud for you guys for staying here on a Friday. It shows your dedication. I used to tell my wife I love this kind of stuff, and and it showed. I became really involved. So at this point, if there are any questions, is engineering required for competition? No, I don't think so. It is not. It's a good thing to have, just a little notebook for just record keeping, Vanya, for yourself or for the class, for the project. It's always good to have documentation. You might be able to present it if the present. I mean, most of the competitions I've been with. I mean, this is my first year with CSTEM, and it's always good to have some type of reference, even for your own good. Sketches, ideas, questions the kids might have, and maybe, you know what, I'll put it on the CSTEM break and ask me. So definitely, it's a good thing to have. I don't think it's a requirement, but it's definitely, but I'll check with you and I'll verify. Any other questions at this time? Anyone else? If there are any more questions, well, I want to wish any forms for the students, Modest. Okay, Mr. Mendoza, any forms? Um, I will write this down and contact the CSTEM staff, and I will definitely try to post that answer back to you on the CSTEM break, Mr. Mendoza. Okay? And I'll make a quick note here on my notes. Forms for students, and I'm pretty sure there's going to be some type of forms to usually they usually are. Okay, Vanya, thank you. Forms are usually on CSTEM break. I figured. Thank you so much. Hopefully that answers your question, Modesto. And all this stuff will be available starting tomorrow. And I'm pretty sure, yes, yes, definitely before a competition, all forms. Way beforehand if you can. So you get them in earlier, the better. It always helps out. All competitions, they really appreciate that, because a lot of the people here are volunteers, and then we devote our time to help and help students like you guys are. And like, again, I want to applaud you for you guys being here, and hopefully I wish you a lot of success, and hopefully you can learn and get as excited as I used to be when I was in your shoes, and help students out.
Have a wonderful weekend if there are no more questions.
You're welcome, everyone. Goodbye.